Let me introduce the test transformer produced by UHV. This is a GTB-15kVA/120 kV AC/DC Hipot test set. Now connect a silicon stack. Since the silicon stack is long, to prevent the silicon stack from falling and damaging the equipment, it is supported by an insulating bracket. Now it is rectified by the silicon stack and can form a DC voltage. Before the test, the black ground wire should be plugged in here. Then the two yellow wires at both ends are instrument wires. It is relatively thin. The two thicker green wires are output wires. It is mainly for the input on the dry-type transformer. The instrument wire is connected to the instrument on the transformer. These two are power lines, 220 volts power supply. It can be directly connected to the normal power supply. This black line is directly connected to the ground on this side. The ground wire on this side is also clamped on the black clip. A ground wire is used to connect it to the ground. These two are instrument lines. Note that the instrument line and the input end line must not be connected reversely. The instrument end has two yellow lines, corresponding to the two instrument lines on the console, corresponding. This is the input line, that is, the output line on the console, they are corresponding. Be careful not to connect them reversely on both sides. Connect them reversely, the transformer will burn. What you see now is the top of the test transformer output. If the top output is not connected to the silicon stack, it will output 120 volts of AC, up to 120 volts. Now because a silicon stack rod has been added, it will be rectified into DC, but you need to pay attention to one thing here, don't install the silicon stack upside down. You can see this indicator, the direction of the arrow points to the output end. You must follow this direction, the arrow points to our output end. This is the wiring here, don't connect it upside down. Now it is the other end of the silicon stack. From this end, it is directly output to the test product, to do a withstand voltage test on it. What you see now is the insulating bracket. The purpose is to support the silicon stack rod, so that it can form a more reliable and safe insulation distance to the ground. After connecting the power supply, turn on the air switch here. The indicator light comes on. After it lights up, it returns to 0. Click Start. The red high voltage is turned on. Press the knob to increase the voltage. Here can see that the voltage has been increased. For AC, see above meter, and for DC, see below meter. We will not increase the voltage now, because the space is limited today. You can now turn on the timer switch, and you can see that the time is set to 10 seconds. When the time is up, it will sound an alarm. Then turn it off. When the time is up, it will be reset to 0 directly. The instrument clicks on the high voltage disconnect. It has now been reset to 0. Disconnect the power supply of the circuit breaker. Disconnect its input power supply as well. Now we can discharge. When discharging, perform the resistance discharge first. When the resistance discharge senses that there is no voltage, then put it into direct discharge. There should be a resistor here, perform the resistance discharge, and then perform the direct discharge. For safety reasons, discharge both sides. After discharging, you can remove the wires.